Okay. So we know that the given function is symmetric in alpha and beta when its value doesn't change on interchanging alpha and beta. That means f of alpha comma beta has to be the same as f of beta and alpha. So let's check for the first function. Alpha square minus beta should be the same as beta square minus alpha. So alpha square minus beta square is equal to beta minus alpha, that is alpha minus beta, alpha plus beta is equal to beta minus alpha. Now alpha minus beta is common and here we have alpha plus beta plus 1 is equal to 0. So here we have the condition alpha should be equal to beta or alpha plus beta plus 1 is equal to 0. So basically, for this function to be symmetric, the condition is that either alpha should be equal to beta or alpha plus beta plus 1 should be equal to 0. That means that the function is not symmetric because for a function to be symmetric, for all the values of alpha and beta, f of alpha beta should be equal to f of beta alpha. But that is not the case over here. So the first function is not symmetric in alpha and beta. Let's try for the second one. So we get alpha square beta plus alpha beta square is the same as alpha beta square plus alpha square beta. So all the terms cancel out and the function is in fact symmetric. Now for the third one, it will be ln of alpha minus ln beta should be equal to ln beta minus ln alpha. That means 2 ln alpha is equal to 2 ln beta. Taking anti-log, we get alpha is equal to beta. That means that the function is symmetric only when alpha is equal to beta. But that is not what we want. We want the function to be symmetric irrespective of the values of alpha and beta. So the third function is not symmetric. Coming to the fourth function, we have cos alpha minus beta should be equal to cos beta minus alpha. Now we know that cos A is the same as cos of minus A. Therefore, we can write this is equal to minus beta minus alpha. So that will become cos alpha minus beta. Therefore, the function is symmetric to each other irrespective of the values of a and b. So this will be a symmetric function. We have to form a quadratic equation, the roots of which are this and this. So let this be equal to say gamma and this is equal to delta. So the quadratic equation will be x square minus sum of roots, so that is gamma plus delta x plus gamma delta is equal to 0. So simplifying, we can write gamma as alpha minus beta square into alpha plus beta into alpha square plus beta square plus alpha beta. This into this is alpha square minus beta square, and this into this will be alpha cube minus beta cube. So this can be written as alpha plus beta the whole square minus 4 alpha beta into alpha plus beta, and this can also be written as alpha plus beta the whole square minus alpha beta. So if we observe this equation, alpha plus beta will be p. This is p square minus 4. Alpha beta will be q, so that is minus 4q. Alpha plus beta is p. This is again p square minus q. And this is gamma. Now if you observe delta, we will see that it is just alpha square beta square into alpha plus beta. So that is q square into p is equal to gamma. Now substitute these two values of gamma and delta in this equation and we will get our required answer.